Hello. Oh, I fixed it. All right. Thank goodness. So is it recording now? Oh, it's been recording this whole time. Okay. All right. I think we're finally ready. What are you guys doing this weekend? Do you hand out candy? No? You just, what do? You go trick or treating stuff? No, right?
Yeah.
You do?
I tried to go trick or treating, but it's just not good.
Oh, I'm such a silly goose. We don't have to start chapter 5 because we already started it. We're on section 5-3, right? Yes, okay.
Well, clearly that means we're ahead of schedule, so we just watch it.
I know about all that. Okay, 5-3. Now we're getting somewhere. So these are parallel line theorems. Okay, so the first one that we're going to look at says if two lines are parallel, then all points on one line are equidistant from the other line. So let me give you a moment to jot that down, then we'll draw some pictures displaying what this means. Okay, so if you have two lines that you know for a fact are parallel, let's take these two and let's assume that I do know for a fact that they are parallel to each other. So I will go ahead and mark them as such. What this theorem is telling us is that we are allowed to come in here, and if I wanted to find the distance between, let me just pick a point on this line, let's say point A. Do you remember how we talked about measuring a distance from a point to a line? How do we do that? Like if I wanted to actually measure how far is point A away from this line right here, how do I measure a distance like that from a point to a line? Sam? Yeah, how do you measure the distance from a point to a line? You have to blank a blank. Drop a perpendicular. So we would, from that point to the line, I would have to drop a segment that is perpendicular to that. That's how we measure the distance between a point and a line. So what this theorem is telling us is that you take any couple points, so I'll pick another random point, call it B. if I drop another perpendicular, this theorem tells me that these segments that I just created, I'll call them AD and BC, they have to be equal in length. Which makes sense, right? If they're going to be parallel, the distance between them, no matter where I go, as long as I'm dropping perpendiculars all the way, should be equal. So if you imagine like a ladder, right? Each rung of the ladder should be equal in length. If I have the sides of the ladder parallel, each step or rung, right, would be equal in length all the way up, assuming it's just a straight ladder, not like one of those funny ones. So yeah, that makes sense. That's what we're talking about here. So if I ever needed to, I could drop a perpendicular between parallel lines and get congruent segments, which you never know when that could help me. You never know. Okay, that makes sense, right? All right, cool. The next one. The next one tells us, this one's so neat. I like this one a lot. If three parallel lines, three, not two. If three parallel lines cut off congruent segments on one transversal, they do so on every transversal. This is so neat. So again, let me give you a moment to jot it down and then we will draw it. Sam, would you shut the light off while you're there? Thanks. Okay, so for this, we need three parallel lines. So go ahead and draw yourself three, and you want to make them about equal distance apart from each other. So kind of like that. Because here's what has to happen. You have three, oh, let me mark that they are all parallel to each other. Okay, so I have three parallel lines, yeah. And now what I need is a transversal, and I need that transversal to have the pieces in between the parallel lines cut equally. All right, so if I just go ahead and I'll take this purple one here. If I just draw myself any old transversal here, a little bit darker. Okay, so I have my transversal. So if it is true that these pieces are equal to each other, that means any other transversal you draw across these same three lines is also going to be cut equally. Not necessarily the same as these, but check this out. So maybe I'll draw another transversal that's sort of even at a greater slope here. These pieces in between the parallel lines, if one transversal is cut equally, every transversal will be. Isn't that something? I love this one. This can help us quite a bit. Once you recognize that there's one of them that's cut equally, oh, it unlocks so much for you. So many other pieces, any other ones you have. Now, sort of building off the same idea, I have to flip the page, but here's what I want to show you. Well, let's do it this way. Remember from the last chapter, all the segments in a triangle, altitude, median, blah, blah, blah. Can you draw for me any old triangle you want, and then go ahead and draw me a mid segment in that triangle. So draw any kind of triangle you want. It doesn't matter, any type. And then I want you to draw as best you can a mid segment in that triangle. Where does the mid segment, what does it have to do to be a mid segment? Sam?
Split the triangle.
Yeah, so it splits two sides. So that side would have to be equal to itself, and this side would be split too, right? So it has to join two midpoints of my triangle. All right, so I have a midpoint of one side, a midpoint of the other. Did you know there are two ridiculously fun facts about this mid segment that we haven't talked about yet? One of them, I bet you could come up with right now, especially sort of using what we just talked about. Maybe, yep.
The line mid-segment and the base segment are parallel.
They are. This is wild, okay? So check this out. I want you to imagine, you don't have to draw this part, but what if I added an auxiliary line that went through the vertex up here, and I drew that auxiliary line so that it was parallel to the bottom? Look what's happening. You have these transversals that are getting cut equally, which means that this line, if I just extended that, that would also have to be parallel. So in any triangle, this is going to be true. So look at the one you just drew. If you drew it accurately, doesn't matter what kind of triangle you have, obtuse, acute, right? Doesn't matter. When you draw in the mid segment, oh my gosh, so big star for this, because this is so cool. The mid segment in any triangle is, we're going to have two fun facts. The first one is that it is parallel to the third side. And this next fact, I know I tell you a lot of times, like, hey, don't just believe something is true because I tell you that it's true. This next one, it's actually super easy to prove it using something called coordinate geometry, which we will do sort of at the end of this course. If you don't mind, I want you to remember that I am going to prove this to you when we do coordinate geometry, because that's really your easiest way to do this last piece. But the fun fact about the mid-segment, not only is it parallel to the third side, do you want to make a guess? What else is true? You're not going to believe it. And it's true every single time. It's always parallel to the base, and there's something else. And it's, I'll give you a hint, it has to do with the length of the mid-segment. Person?
It's always half the length of the base.
It is. It is half the length of that same base. So not only is it parallel to it, it's half its length. What? I know. Half the length of the third side. That is so cool. So in other words, if I'm just going to add it to my diagram here. If I know that the base has a length of 2y, let's say, this would always be a length of y. How do we feel about that? It's so cool. I know, you guys are like mind blown. I totally get it. All right. Anybody have any questions so far? Because believe it or not, that's pretty much all I have for 5.3. I don't think I want to go on to 5.4 yet, so why don't we just get our homework done and out of the way, and then we won't have to worry about it over the weekend. Okay. So let me see. I'm gonna change what I want you to do a little bit. Okay, so I'm gonna want you to do. Okay. All right, I think this is good. Okay, nice and easy-ish, I hope. Whoa, 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 whoa. $180 to $182, 718, and self-test one. That's it. Okay, let me know if you have questions.
Is it 7 through 18, or is that the self-test? or is it
No.
the and?
The end. Yes. Okay. I will post your notes in just a minute.
Oh, yeah. I forgot that.
Sorry.